Derivatives with E, quotient rule, Leibniz's notation. So, as shown before in previous videos, when you have a function and it equals e to the power of x, when you derive that, you will get e to the power of x. If you have e to the power of kx, when you derive that, you will get ke to the power of kx. Basically, you keep, when you derive e to the x, you keep e to the x. You keep whatever is the power of e, you keep that and e the same, exact same, except you multiply it by the derivative of whatever's in the brackets. So over here, you have e to the x. It's technically e to the 1x. And when you derive that, what you get is you still have e to the power of 1 times x, but you times it by 1, the derivative of the bracket, the derivative of the power. But because when you multiply by 1, you don't worry about it, it's just e to the power of x. Just like over here, e to the power of kx, when you derive that, you end up with e to the power of kx multiplied by the derivative of kx, which is k. And over here, this is just refreshing. Quotient rule is when you have a function y, and inside it you have two functions, u, and which is divided by v. And when you derive y, you end up with v multiplied by derivative of u minus u multiplied by the derivative of v all over v squared. So, for an example, for 1, we'll say y equals e to the power of x over 2x. Now we know that we have a function over a function, we use the quotient rule. So, the quotient rule is v multiplied by derivative of u over x minus u multiplied by the derivative of v with respect to x all over v squared. So we need to find u, the derivative of u, v, and the derivative of v. U will just be e to the power of x, and v will just be 2x. The derivative of u is just ex, because the derivative of e to the x is just e to the x. The derivative of v, which is 2x, would be just 2. So, if we were to sub this in, which we will, v, 2x, multiplied by derivative of u, which is just e to the x, minus u, which is just e to the x, multiplied by derivative of v, which is just 2, all over v squared. So, because you have e multiplied by both 2x and 2, you can factor that out. So, we'll factor it out by saying ex bracket 2x minus 2, because if you expand these brackets, you will get 2x ex minus ex2, and that'll be all over 2x squared. If we were to expand that, you would end up with 4x squared. And that there is the first derivative of this function, this function up here. Second example. Y equals cosine of x over e to the x. We know when you have a function over a function, the derivative, we follow the quotient rule. So u we'll call cos x, and we'll call v e to the x. The formula for the quotient rule is v multiplied by derivative of u minus u multiplied by the derivative of v all over v squared. So we need to find the derivative of u and the derivative of v. The derivative of u is just the derivative of cosine of x, which is negative sine of x, and the derivative of v is just e to the x, because e to the x, derive that, you get e to the x. Okay, so if we were to sub this in, we would have v e to the x multiplied by derivative of u, which is negative sine of x, minus u, which is cosine of x, multiplied by the derivative of v, which is e to the x, all over v squared, which is just ex squared. So if we were to factor this out, the e on the top, we would have dy over dx, dy over dx equals ex, and then inside the brackets you would have negative sine x minus cosine x all over ex squared. Now, because we have ex here and ex squared here, we can essentially get rid of the 2, get rid of the x altogether. So if I were to rewrite that, let's put this up here, continue on, you would have dy dx equals negative sine x minus cosine of x all over e to the power of x. And that there is the first derivative of this function up here. Now for a third example, let's say y equals 3e3x over sec x. Make it a little bit tricky. Basically still same, u over v. If we go to label them, u would be 3e3x and v would be sec x. Same as before, you have v multiplied by derivative of u minus u multiplied by the derivative of v all over v squared. So we have to find the derivative of u multiplied by the when we have to find derivative of e. So the derivative of 3e3x, just like before in that where you had, I'll bring it up, just like before when you had y equals e to the power of kx, the derivative is ke to the kx. You're basically doing e to the kx, and then when you derive that, you have e to the kx multiplied by the derivative of kx, which is k. So you end up with ke to the kx. That may sound confusing, but just like here, we'll put the 3 there. 3 doesn't go away, but you have e to the 3x multiplied by the derivative of 3x, which is 3. So we could multiply 3 by 3 and end up with 9. So we would have 9 times e to the power of 3x. And then for the derivative of v, we would end up with 10 x sec x, because the derivative of sec is tan x sec x. So if we were to fill this in, we would end up with v sec x minus multiplied by the derivative of u, which is 9e3x, minus u, which is 3e3x, multiplied by derivative of v, which is tan x sec x, all over v squared, which would be sec x squared. So I'm running out of room here, so I'll grab another page and I'll continue on simplifying. So basically you can cancel out, because there's a minus here, you have to, if you were to cancel out a sec from the bottom, you would have to cancel out one from either side of the minus. Or if there was an addition, you would have to do the same. But if we wanted to cancel out a sec here, we would have to cancel it out from either side of the minus sign. So dy, I'll show you what I mean, dy over dx, we would cancel out the 2, and then we'd have to cancel out the sec here and the sec there. So we would end up with 9e3x minus 3e3x multiplied by 10x, all over sec x to the power of 1. Just write it as sec x. And so we can actually simplify this further and I'll write it first and then I'll explain it. So what I did here is, if you expand the brackets here, you'll get the top line 3e3x. If you multiply that by 3, you get 9e3x. If you multiply 3e3x by negative tan x, you get negative 3e3x multiplied by tan x. So here, it's just a simple, well, not a simple, it's a simplified way of doing it. So this here is the derivative, this bottom bit, is the derivative of this up here. Thanks for watching.